Hi. Okay, one of the things that we don't consider, I think, in physics is charge. And charge is the way that began is that there is a positive charge and negative charge, and they would use different sort of things to create a positive charge. And there would be two spheres on strings, right? And what would happen is that they would either move apart if they were like charges, or they would move closer if they were unlike charges. Opposites attract, the same repels. Okay. That's as far as we got with charge. What is charge? We don't even know what that is. And concerning dark matter and dark energy and the universe and the fact that it is expanding and that expansion is accelerating, is something that we may want to keep in mind or do some work on as far as charge. Because if there is a small amount of difference in the charge of an atom, the positive and the negative, and I mean like 10 to the negative 50 or 10 to the negative 60 coulombs, it's very small, it's negligible. Even if you have a house or boulders or whatever it is, it won't make that much of a difference as far as attraction and repulsion. But if you have a galaxy, there's a lot of energy there. There's a lot of mass within that galaxy, and if you have that much, and there is a net positive force from all of the atoms that are inside of that galaxy, that there actually will be a positive force that is being emanated from that. And another galaxy, similarly, has a net positive force because of the difference in positive and negative within the atoms. When you take that many atoms, and that's a lot of atoms, the result is an actual force that pushes the galaxies away from each other. And the tip to this is the acceleration of the expansion of the universe. If there is that, and there's another galaxy over here, there's another galaxy over here, they're all moving away from each other. And they're not just moving away from each other. Now, you did have the Big Bang, and they are sort of going away from each other, but you would expect that to be constant. You would expect for the expansion of the universe to be constant. The fact that it's accelerating, that's going faster, leads us to believe, or leads me to believe anyway, that there is a force. There is a force that is being emanated throughout the universe. And it seems to me that it could very well be that the difference in charge, a very, very small difference in charge, between an electron and a proton, or positive and negative. And it really doesn't seem that it should be that. They should be exactly equal. Now, in our measurements, they're very close to equal, but it's the precision that and the accuracy that when we measure it far enough, there should be a point, and this is what I maintain in my theory, that there's a small difference. And when you have a lot of atoms, then that causes a repulsion. Where if you have a smaller amount of atoms, there's an attractive force, and that's gravity. Do we know what gravity is? No. It's one of the forces that still remains. We can describe it, we know how it works, but what it actually is has not yet been determined. So I wanted to leave that with you. Okay, so this is getting long. Take good care. Thank you for listening. Bye.